Alrighty, folks, welcome. Today we are going to talk about identifying minerals in the lab. All right, and I don't want to say I often forget, but I, I often forget that many of you guys have, excuse me, actually all you guys, if you took Earth Science, have done some version of this in high school or eighth grade whenever you took Earth Science. Um, the difference is that at the college level, I hold you responsible for probably slightly more than your Earth Science teacher did back in ninth grade. I test a little differently, okay? But the procedure for identifying minerals really hasn't changed. And I spend a lot of time going over it. Um, and I keep going back and forth in my head on whether or not I need to take all this time because arguably you guys have done this already, but it was potentially 4 years ago. And I know things that I was taught to do 4 years ago, I don't necessarily remember. Um, so I still do it. So bear with us. Some of it you will, oh yeah, I remember that, da 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 da. And some of it might be a little different. I don't want to say new, but presented a little differently. There's definitely a procedure that I want you guys to go through, and I will try to make that clear. After a good bit of talking, I never talk this much in lab. I really don't. But minerals needs it. So after a good bit of talking, we'll stop and we'll do some of the stuff with one of the minerals in front of you. Okay? And then I got to go back to talking for a little bit longer. And then I'm going to set you free to work on your specimens. Now, the object of this lab, the goal of this lab is not to make you guys mineralogists, okay? If that were the case for some strange reason, we would have an entire 14-week class for you, mineralogy. And there are mineralogists out there in the world. So it is actually a job, not just a degree and not just a class. But right now, this is part of a bigger thing in Geology 101 where you need to learn about the basic identifying principles of minerals. And the way that we judge whether or not you've done that is that wonderful mineral test, the mineral practical. Practical is what we call a test in lab. Practical experience, I guess, is what they're saying. And what it boils down to is you guys are literally going to walk around the room with an answer sheet and say, oh, that's a hunk of rose quartz. It's a silicate. Oh, that's a hunk of galena. It's a sulfur. And so on and so forth. Mineral name and mineral group. In the end, that's what you're being held accountable for. So you might be thinking, well, okay, why don't you just show me 31 specimens, tell me what they are, and I'll memorize them by the time the test comes through. Yeah, I'm sure most of you could actually probably do that. Unless, God forbid, the color varied slightly or the shape of the mineral, because we do, our brains, the way they work, we memorize shapes and colors very, very easily. At least most of us do. So if it's a slightly different shape, it's going to throw you off. And then this, that, and the other thing doesn't work. So we're going to take the time to learn the properties. Remember when we gave you the definition of a mineral in class, that it was a naturally occurring inorganic crystalline and then composed of a fixed or unchanging set of chemical and subsequently physical properties. So it's those physical properties we're going to go through today. All right. And the idea is then if something does just look a little wonky come the day of the test, that you could say, okay, well, I remember this. Okay, it feels really hard. It does, even though it's not the right exact color or maybe the right exact shape, you'll have other things to fall back on. So that's sort of the method of the madness. It is the scientific method. There is a procedure, as I said a couple moments ago, that I'm going to have you guys walk through, hopefully with some consistency. And you should arrive then at the right answer. But just in case you don't, we always do this lab, all labs really, in pencil. So when we come to the point in a little while where you're going to be writing stuff down, if you don't have a pencil and you can't borrow one from your neighbor, I have a handful up here. All right, they don't all have erasers on them because of that very reason, but you know, you're going to make some mistakes, and you're going to want to erase instead of scribbling out in your books. So, lab number 2 in your lab book here. For those of you in earth science who might be looking at this, this is a lab out of my geology lab book. All right, and this kind of follows along into what you guys have in your lecture books, in both classes, really. But you guys are just in earth science, are responsible for way less rocks and minerals. And the same process, speaking of which, for you guys back to people in front of me and folks in geology, the same idea goes for when we do the rocks, okay? We're going to give you a little bit of introduction. You're going to identify the rocks, but in the end, it's just name and what type, okay? We're never going to ask you for properties. And you'll see as you go through this, you'll be actually quite thankful that I'm never going to say, what is the luster of this mineral? What is this? What is that? What is its hardness? Because first of all, that's way more things to memorize. Okay. Even though arguably you should be able to look. But even though these are unchanging physical properties, that's in an ideal setting. And a Geology 101 lab is far from an ideal setting. So, you know, every piece of crystal quartz on the planet might be shiny and beautiful and all pointy on one end and these beautiful, you know, looking like the Washington Monument kind of things. But this is a 101 lab. We've got some pretty beat up looking stuff. Even my test specimens have seen better days. So, you know, we want to go at this with a bit of flexibility nonetheless. So as I said, physical properties, this is how our brain works. Okay? You guys, we're probably getting to a point where my Terminator references are going to be outdated, but I'm going to assume that at least a good chunk of you have still seen the movie Terminator, all right? And I'm thinking about one scene, I forget where it is in the movie, but he walks in, he does it a handful of times, and he's looking around, scanning, so to speak, and you see this little blip in the upper screen where it says, you know, looking, oh, subject found, does it equal whoever Connor, I forget the person's name. Your brain does that. You don't get a little readout, but your brain does that every moment of every day when you're wandering around and thinking. When you walk into a room and you know your task is to sit down, your brain scans around the room and looks for an object that fits the description of chair in your head. You don't think about it actively, more than likely, but it's going on. My point is that this isn't a new hard thing that you have to learn. You're walking in the mall, well, maybe over the weekend, and you see somebody 50 yards down, 3 or 4 stores down, and you're like, oh, I think that's Sally. Well, why do you think it's Sally? Well, it's about the right height for Sally. It has the same color hair as Sally. It's dressed the way Sally dresses. Those are all characteristics. Those are all properties. So what makes this hard or what makes this different is, well, you've got to learn 30 new friends in the next couple weeks. Okay? That's, if anything, what makes this difficult or challenging. And even most of these properties are words that you know. Luster you don't exactly use, but you probably got a good idea what luster means. Speaking of which, let me turn the lights on in the room. So luster is a term we use to talk about how shiny something is or isn't. It's lustrous, right? You may not say that, but if someone said it, you understand what they were going for. Well, we do have a handful of adjectives there at the end of the luster paragraph. You don't go straight to those, okay? In fact, you're going to ask yourself one question. Is it metallic or non-metallic? Right off the bat, at any rate. And this is actually a harder question than you might think. Because we're not asking if it's a hunk of metal. We sort of are. But we're asking if it's a shiny hunk of metal. It's different. So let's take these lovely cabinets in the room. We've got a cream one over there. We've got some dark gray ones in the back corner. You guys at home maybe think of a filing cabinet, just your generic old cream-colored metal filing cabinet. They are metal, right? But it's not shiny, shiny, shiny like metal. Well, what do I mean shiny like metal? Well, look at the handles. Look at the gas valves going down the center of the lab tables. For those of you at home, maybe think of your kitchen sink faucet, the handles on your shower, the spigot on your bathtub. Doesn't have to be silver. Everything I just mentioned is sort of chromy, right? Doesn't have to be chrome colored or silver, but it needs to shine like that. Now, you're not going to come into painted minerals, of course, okay? But what can happen to metal? Well, it can get oxidized. It can get rusty, and it can take that finish away very easily. Or it could be so granular that it doesn't really get an opportunity to sparkle, and so on and so forth. And then, of course, there's a whole slew of minerals that aren't even hunks of metal. Now, that's the tricky part, because you're going to see some shiny stuff right off the bat. If you want to call something metallic, it has to actually be made of metal, okay? That's the clincher there. We've got other words. We'll talk to you about them in a moment. But if you want to say metallic, make sure it's actually a hunk of metal. And that's why you have 3 or 4 brains in your group. And you folks at home, that's actually the hardest part about this lab. It's not even not having so many specimens in front of you. It's not having anyone to share your thoughts with. All right, that does stink. I feel sorry that has to happen that way. All right, so I'll start off by saying very few of your specimens are going to be metallic. All right. In fact, you have none in your box today. We're looking at specimens 1 through 12, I think, for those of you at home. Those would be on your virtual mineral gallery on the web. Okay, 1 through 12 is the same. The numbers at home are the same as, the numbers online are the same as they are in the room here. For those of you with the box kits at home, we're not talking about your boxes. Those have entirely different numbers. You only have 4 minerals and 4 of each of the 3 types of rocks in there. So that's a totally different numbering system. But what these guys are looking at right now matches up to the numbers in the online mineral gallery. So we have 1 through 12, and I'm telling you right now there's nothing in there metallic, but you're going to forget that after me blathering on for 45 minutes, and I'm going to hear probably at least one group say, oh, that's metallic. And I'm going to say, is it a hunk of metal? And you're going to say, oh, no, it's not. Okay, so what's the other word we use? Those other words are down there in bold in the last sentence of the luster. Now, you certainly can sit there and bicker with each other about which word, which adjective is appropriate. But I would wait. I'm going to ask you to wait until we actually get to the correct table. The ID table is a little farther in. If you guys read the lab, you know what I'm talking about. Because that's going to narrow stuff down for you a lot. You might be going back and forth for 10 minutes on whether or not something is vitreous versus pearly. You get to the tables and you find out you don't even have a pearly option. Something like that. Okay? So right now, you just get in, and I'm going to say this over and over again, and you're going to ask yourself 3 questions, bing, 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 and then you debate. Because these first 3 questions, luster, color, and hardness, will get you to the correct identification table. Then you can grumble till you're blue in the face. I don't care. All right, so anywho, the majority of these specimens, you're going to be non-metallic. Once you decide which table you're on, you're going to need to worry about which adjective to use. Vitreous. Vitreous is fancy talk for glassy, okay? Don't use this word a whole lot anymore, but it does mean glassy, shiny, okay? Pearly. Anybody wearing pearls today? You don't see a whole lot of pearls anymore. In fact, I think in 22 years of doing this, I've never had anyone say, yes, I have pearls on. But you all know what a pearl is, right? Yeah, they're kind of cool. They're seriously not in vogue anymore. I get it. But they are cool things. What's a pearl? A pearl is whitish. A pearl sort of has that swirly, satiny luster to it. And over here, I quite purposely borrowed a painting term. All right. I know that a lot of you guys maybe haven't painted a room in your house, let alone an entire house. But you are familiar that in the painting world, they have terms like flat and glossy and satin. And okay, think of those when we're doing this. Because pearly is kind of like satiny. It's not super gloss. It's not super shiny. That's vitreous. But it's not flat either. It's got just a little bit of shine to it. Because the thing about luster, remember I said it doesn't have to be silver. Luster is independent of color. So this pearly things, they don't have to be white. They could be peach. They could be purple, whatever. So what else is left after you take the color away from the definition of a pearl? That's what you got to think about, okay? So like I said, they're not quite so shiny. In my mind, there's also sort of a depth to it that's kind of swirly if you think about a pearl. The color's sort of deep in it. And yeah. A lot of this you'll learn sort of reverse engineering ways. You'll get to the, like I said, those tables at the end and you'll say, okay, well, I didn't think that's what pearly meant, but every other property matches up, so this one must be pearly. Earthy. Earthy is grubby, grungy kind of stuff, going back to that rusty mineral, something that's covered in rust, oxidation, you might say, feels and looks earthy. Luster isn't really about feel, but think about it, stuff that is sort of not so shiny and grubby is going to have a different feel to it. So we want to engage all of our senses, even though luster isn't about texture necessarily. Opalescent. I'm going to ask the same question, but anybody wearing opals? This one really is a shame. Opals are really cool. Picture a pearl, but with this iridescent flash of like peach or blue in it. All right. Mother of pearl is something very similar. And I thought about changing this property to iridescence, but none of the other textbooks, lab books, did that. So I kept mine at opalescence as well. You don't have a piece of opal, okay, but you will have something that has that flash. When you turn it just right and it hits the sun, hopefully you're looking at it on a day slightly sunnier than today, it's going to flash this really cool color at you. And that's sort of your tip or your hint that you're looking at that mineral. Lastly, we have resinous. Resin, think of a tar or a plastic, right? And these are almost, saying they look man-made is a bit of a push, but boy, they're not going to look like your gemstones that you're going to see those shiny pieces of quartz and so on and so forth. They're not going to look like hunks of metal. Necessarily. They just something is off about them. Amber is a great example of resinous. The problem is all the amber you guys have ever seen has been polished, at least as well as you can polish amber. It's kind of soft, so it's hard to polish it. But if you've seen it in jewelry, it's not quite resinous anymore. It's approaching vitreous. Think of dried maple syrup. That's kind of where resinous sits. Don't get too creative. Please try to stick to these adjectives, okay? So that's luster. Color. Again, something you'd think would be fairly simple. The problem is not everyone walks into this room with the same Martha Stewart palette in their head. All right? What you might want to call ecru, or more than likely, let's say what you might want to call off-white, someone in your group might want to call ecru. They're not right, you're not, or they're not wrong, you're not wrong, okay? Your sheets are not going to be identical to one another. Yeah, hardness is hardness. There's no question about that. Cleavage is cleavage, and so on and so forth. But things like color, and especially your descriptions, I'm jumping ahead of myself here, but there's a place in there for description. You want to write something that's helpful to you. If you don't know what ecru means, please do not write down the word ecru. Write down cream or off-white or whatever. Now, again, that comes a little later because this question, when you pick up the mineral in the first moment, second moment, because the first moment was luster, it's a really simple question, light or dark. That's it. Some of them are fairly easy. Something that's clear, something that's white, something that's yellow. Yeah, we'll call those light colored. Something that's brown or black or navy blue, gray, dark gray at any rate. Yeah, we'll call those dark colored. But there's a lot of in-betweens. And again, that's why you have a couple brains in each group to think about stuff like that. Well, where do we put green? I don't know. Is this dark green? Is this light green? Good question, and so on and so forth. So again, you pick it up, and you're going to know this even before you pick it up or as you're picking it up. Is it light colored or dark colored? You move on until you get to the tables. Hardness. You guys probably learned about Mohs hardness scale back in the day. And Mr. Mohs, I hope his family lived to see some of the profits from this, because in every earth science and geology classroom around the planet, there's a box of little kits called Mohs hardness scale. Your classroom may have had some. I've got some somewhere. They might even be in my storeroom at this point, because they're kind of useless, unfortunately. You remember them? There was like a note card with 10 little chips of mineral glued to them. Usually the name, sometimes a number next to it, its hardness number. But what would happen if you, God forbid, you actually tried to use this thing, the glue would snap, or it would dry out even over the years. And so you'd have 3 or 4 pieces of mineral in the bottom of the box, a card with some minerals on it, some blank names on it. You didn't know what was what. You couldn't do anything with them. Now, back when he set this up, it was awesome, because you got these guys, maybe they had a truck, but more than likely they were going out on a horse or a mule. And actually, I don't have a whole lot of rock. I do have a decent amount of rocks, but you see my classroom, all right? People's offices are just as bad. Their homes are just as bad if they're geologists and they collect rocks. The last thing you need to do is bring another damn rock home, okay? But you got to take good field notes. So how do you take good field notes? Well, you're worried about the color, the luster, and hardness. So how do you get exacting? Well, this is where this came in. They could have a little kit, and even if it was in a pouch like marbles or coins or whatever, they knew, because they were, good old rugged Marlboro men kind of geology people. And I say that it's not there were just not any women geologists. Paleontology, we had some women finally, thank goodness. All right, but back then out there, it was the guys. And so they'd whip out this, okay, I need this hunk, and they'd scratch it. No, it's a little softer than that. Okay. And it was a way of gauging rather accurately the hardness of the specimen. And you didn't have to bring it back to the lab then if you took good notes. Well, like I said, that evolved into something completely useless. Nowadays, we have a handful of tools that pretty much anybody could have, even students at home. Fingernail, a piece of copper, a piece of steel, and a piece of ceramic. And we don't even use the ceramic for hardness. We do use it a little bit later for streak. So 3 things, and you could get a fairly good idea of the hardness, at least to get into the tables, and then you'll know the exact hardness. Now this is where we pause and you guys actually start to get to do something. Whoever the mineral box is closest to, if it's in the middle of the table, that's great. We did number 3 the other day, and that was way too easy. Let's do number 2 instead today. So grab number 2. They're in order. And again, for you folks at home, this matches up with number 2 on the online mineral gallery. All right, we're going to go slightly out of order, but I just want to point out how obvious this is. Light colored or dark colored? I can't hear you. They can't hear you. Light colored. Why? What color is it? White, for those of you not looking at the mineral gallery. open another tab and put up the mineral gallery. Or maybe I'll take a picture of this and put it with this recording. So it is white, okay? Arguably, we would call that light colored. It's not always going to be that simple, though. All right. So let's go back to the first question that you were supposed to ask. Metallic or non-metallic? Non-metallic, okay. Is it a hunk of metal? No. Is it shiny? Yeah, kind of. There's certainly shinier things out there, but it's not shiny. It's not all dusty. It's not all rusty. So arguably it's shiny-ish. So we're going to call it non-metallic, and we have a good idea of what we'll call it once we get to the actual tables here in a moment or two. Now, you guys aren't writing anything down yet. Don't worry about your fill in the blanks yet. We're just talking right now. Just talking. All right, so group 3, where is your specimen? Is it out somewhere? Okay, good. Couldn't see past all the crap on the table. Okay, so hardness test. This has to be done correctly or you'll get like the totally wrong answer. Sometimes you scratch the mineral with the tool. Sometimes you're scratching the tool with the mineral. It'll take you some time. Finally today you'll get used to it. Then we're going to take a week off. You guys come back next week and you're going to forget again. Ask questions, okay? And if I see you guys using it incorrectly, I try to say something as well. So what's the first tool we want to use to test the hardness? Fingernail. All right, so you've got in the side corner of your boxes there, you got some ceramic towels. You got a whole bunch of tools in there. Poke around. There should be a fingernail in there. No, I'm kidding. You're going to use your fingernail. Do not attempt to scratch your fingernail. Don't drag the mineral across your thumbnail. All right? You're going to try and scratch the mineral with your fingernail. Pass it around to your neighbors. See what they think. Gentlemen, you're going to want to maybe grow your nails for the next month. Okay? They could be invaluable, especially when it comes to the practical. I can say no pocket knives, no keys, no thises, no thatses, but I can't take your fingernails away from you. So we doing any damage? No. Believe it or not, there are some specimens you're going to see where you will scratch this. Okay? If you should scratch the mineral with your fingernail, you stop right there. You are done, and it is, imagine that, soft. Okay? But since we did not scratch it, we're going to move on. What is the next tool that we are to use? Copper pennies. So, supposed to be a piece of copper, because we all know about pennies these days. There's like 1/64th of an inch of copper on these things, and then it's all nickel. But for the most part, they're copper. Believe it or not, and I know copper's worth money, but these tiny little strips, practically, no bigger than 3 matchsticks wide. I'm going to choke, excuse me. Drinking not always a good idea when you're choking. Anyhow, the copper would disappear by the end of the semester. There goes my good video. There we go. I had the tiniest little bit of cracker crumb in there. Okay. Since I'm so bad at editing, that'll probably get left in the video. Anyhow, they would always steal the copper. I don't know why. It's kind of cool to have a piece of copper, I guess. I don't know. We have pennies. If you don't like the penny in there, feel free to toss a different one in. You don't want to use a super tarnished one because you're just scraping the tarnish off at that point. And also, I know it's illegal to deface money, but there's a special subclause in the Constitution or wherever it says it's illegal to deface money that says it's okay for Geology 101 classes. So we're good. Now we switch up, and this time we're going to try and scratch the tool with the mineral. So set the penny down on your lab book. and drag that mineral right across Abe's face there and see if you could do any damage. Pass it to your neighbor. See what they say. You're not petting a kitten here. Put a little elbow grease into it. Any luck, you guys? Group 4 says they were not able to scratch Abe. Group 1, how about you guys? Yeah, Group 3? Group 4, you should try it again. Because this is harder than copper. Now, that's going to happen sometimes, and it's going to get you to the wrong table. All right? The wrong ID table. And that's fine. Again, that's why we do these labs in pencil. But what's more than likely to happen is you're going to get frustrated and not be able to find an answer, at which point you need to ask me a question, and I'm going to ask you these 3 questions. I'm going to say metallic or non-metallic, light or dark, and hard or soft. And usually we get each other on the hard or soft thing. Did you manage to scratch it that time? Okay, good. Yeah, you should be able to. All right. But again, believe it or not, there will be some things that you couldn't scratch with your fingernail, which mean they were harder than your fingernail, but they are softer than copper. You would stop here if you couldn't scratch it, and you would say it is soft. Okay? But we were able to scratch it, so we keep on moving on because this mineral is harder than copper. So the next thing we move on to is a piece of steel. Now this says steel knife. I cannot provide you guys with knives. We have instead dull, rusty nails. We'll talk about that in a moment. Should you have a pocket knife, you are more than welcome to use it. All right? As long as it's not something you could bring down a deer with, I'm generally comfortable having it in the classroom. It's not high school anymore. You are allowed to carry pocket knives. Just make sure it's not some, 99-cent Harbor Freight kind of knife. You want a decent one. Don't bring in your ceramic-coated ones, though, either, because you could scratch that off, and that would be bad. But for the rest of us, we've got nails. You might ask, why give you a dull, rusty nail? Well, they didn't start out that way, and I do every so often buy a box of nails, but believe it or not, a lot of this stuff is actually harder than steel, and very quickly that point tends to round. And they all get rusty. I've had so many suggestions over the years. Oh, get this, they don't rust. They're either coated or they're aluminum, and it defeats the purpose, or this, that, or the other thing. We have to use these, what they used to call 3-penny nail, 10-penny nail, I forget. 10 cents a nail seems a little high, so I doubt they were 10-penny nails. But at any rate, these guys, okay? In fact, you may even find that the head of the nail, the round, skinny part at the end, is a better scratching device than the pointy end. Now, why go on and on about the fact that it's rusty? Why is rust bad for people? Anybody? Everybody. You should all know this. Tetanus, yes. Okay. Tetanus. If you get cut and you get rust in that wound, you could get a very nasty infection. Yeah, and lockjaw. That was like, I grew up in a weird time. We were worried about quicksand, lockjaw, and a couple other things that you never really encountered in life. But lockjaw was, yeah. And more so, importantly, you guys are getting to the age where it's been a long time potentially since you've been to the pediatrician, and your tetanus shot could be wearing out. Just general, it's good to make sure that your tetanus shot stays up to date. So what do we do about that? Well, for one thing, we don't hold the specimen in our hand. And for those of you at home, I'm kind of mimicking the psycho stabby thing or an ice pick. You're not going to do that. You're going to set it on your lab book. And we try to scratch it with the nail. All right, don't try to scratch the nail with the specimen. So we switch. This is where you guys get confused because I'll see you trying to scratch the nail and I'll see just rubbing the penny on the mineral. And believe it or not, it tests the exact opposite of what you want to test when you do them the wrong way. So now we are trying to scratch the mineral with the nail. Please don't puncture yourself, but give it a try. Pass it around. Now, if it leaves a white mark, you think it's a scratch, blow on it a little bit, try and rub it off a little bit, see if it disappears. If it stays, you actually scratched it. Also, you don't want to peck at it because that's testing a different property, sort of like chipping at it. That's called brittleness. And even steel is rather brittle, even though it's quite hard. So we don't want to chip it. We got to make sure, and this is a tough one because it's got a really irregular surface. All right. But we want to make sure that we're doing an honest to goodness scratch, not chipping off pieces. So group one, we'll start with you guys. Any luck? No. All right. Anybody think they scratched it in group one? And everyone else said, no. All right. Group three, how about Jens? No dice? Ladies? All right. Well, you should not have been able to scratch this one. You're right. Okay. Which means that it is harder than steel. Now, this is actually the breaking point for hard versus soft. This is the fulcrum, if you would. If you can't scratch it with the nail, it's hard. Here's the thing, though. I don't want you to jump just to this. Even though this is the definitive test, some of these specimens are so soft that if you go at it with the nail, it's just going to crumble. Once you get good at this, it's going to take all of 20 seconds. Respect the process. Please go through all 3 steps. Okay? But in the end, if you cannot scratch it with that nail, it's hard. So this one is, let's go back and remind ourselves of the 3 properties. Metallic or non-metallic? Non. Light or dark? Hard or soft? All right, what table does that put us on? I've gone back and forth with the Lab company for 3 editions now. They keep making the unimportant bit, mineral identification table, in great big letters, and the helpful part, table 1 metallic luster, in little letters. Are we on table 1? No. But you see how that's the only property. If you have something metallic, go straight to 1. Okay? Don't bother even. You'll have to do most of the other stuff eventually. But if it's a shiny hunk of metal, just go to 1. Table 2, non-light, soft. We decided this was hard. So what do we want? Not 2A, but 2B. All right. So you see how 2B, non-metallic, luster, light colored, hard. All right, first thing you encounter here is color. Now, the last time we did this, I chose 3, which you may have noticed is pink. There was only really 2 options, and one of them was peachy pink, and that was definitely not even close to peachy pink. So 3 was really easy. So this time, this is a little harder. We got white, we got clear to white, we got white, and we got white to gray. Color column isn't narrowing a whole lot down for you. The next thing you would go to is cleavage. Now, cleavage is not the next property in the book, I don't think, unfortunately. Let's go back, though. So you see how you use that. 3 properties, you get to a table. Then you look at the colors, and you get narrowed down. And it was all about luster, I think, was the conversation. So you could have been going back and forth about vitreous and pearly. And let's say we did do the pink one, and you realize that, oh, okay, it's vitreous no matter what. Sorry. And you wasted 10 minutes arguing on what pearly versus vitreous meant. So save those conversations until you get here. I definitely want you to have them, but do it smartly. Do it, in a time-savingly manner. All right. So 3 properties get to a table. Let's go back and talk about some more of these so you guys could actually get on the road here. Back to page 15. And yeah, cleavage is not next. I guess that's what I'll do for edition 4. Put these properties in the right order. Streak. I mentioned that piece of ceramic a couple minutes ago and said that we don't really use it for the hardness test. The reason being, well, there's 2 reasons really. First of all, if you can't scratch it with the nail, more than likely you're going to scratch the heck out of the ceramic, which just means it's hard. The stuff that we have is the hard stuff is really hard. Okay, so there was no reason to do it that manner. The other one is that in a lot of cases it makes a noise very similar to fingernails on a chalkboard, which drives me absolutely bonkers. Some people aren't bothered by that. Very lucky souls. Okay, but I am. So you guys would sit there and make those occasional really horrible screeches, and there just wasn't any point to it. But there is one time when we do need the streak plates. Now, you guys have 2 streak plates, as long as they didn't disappear already. There's a white one and a black one. They're both hunks of ceramic, and they are used to measure streak, to view streak. Well, what is streak? Streak is a powdered residue left behind when you drag a piece of mineral over the streak plate. Here's the key. As long as it's softer than the streak plate. I never used to point this part out. And there was one semester, there was this one group, this was years ago, but still, who raised their hand after a while. And they're like, we're having a problem with streak. I'm like, how could you have a problem with streak? If it's yellow, it's yellow. If it's blue, it's blue. Where's the other thing? Well, we're getting white streaks for everything. I'm like, okay, hold on. Let me get off my butt. And I wandered back. I said, okay, show me one. And they had arguably this specimen in their hand. So they take their little piece of ceramic, they go scratch, 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 tap it on the thing, and sure enough, there's a pile of white powder on the table. I'm like, okay, try another one. Same thing. This time it was like a dark mineral, but they're still scratching on that. I don't think I had the black plates back then. I just had the white ones. Well, you could probably see where this is going. They were grinding up the ceramic, okay? And of course, they were getting white powder because that's what the ceramic's made out of. You have to use a soft mineral. So if you tested it hard, don't do a streak test because you're not going to get a streak. But something that's softer will definitely leave some sort of residue. As I said, though, it's not too horribly useful the majority of the time because if you drag a piece of sulfur across it, guess what? It's going to leave a yellow streak. If you drag something green across, it's going to leave a green streak. And if you drag graphite, it's going to leave a gray streak. It's the color of the mineral. That's what it is. But there are a few occasions, one of your metals, where you drag it across and instead of gray like the color of the mineral, it leaves a red streak. The oxidation comes off on the ceramic. And that's like a key definitive property for that one specimen. So even though you could probably do, $5 bet each time on what color the streak is going to be, keep doing it. Because one time you're going to lose that bet. But it's good to know. So always do streak. Expect it to be the color of the mineral. Sometimes it's not. Oh, transparency. Transparency is not the best property. Your specimen 1 is a great example of transparency. It may be perfectly crystal clear all the way through, but more than likely at the end that isn't pointy, if you have one that isn't pointy on one end, it's rather cloudy. And there's a really great reason for that. These crystals tend to grow just as like little spikes coming out of the walls. And even when you get someone who knows what the heck they're doing, if you whack it too hard with your hammer or whatever, it sends all these little microfractures through and instantly clouds the specimen. What it boils down to is if you've made it this far without knowing the difference between transparent, translucent, and opaque, it's time you learned. Okay? Don't ever let these be your definitive properties, but you may use them as descriptors here and there. Transparent, that's like the windows right there, okay? You can see more or less right through it. Or you know it's crystal clear even though you maybe can't see. You know what transparent means. Translucent, a little different. Translucent, think like glass block windows or frosted windows. The light's coming through and you could potentially even see maybe a shadow or something through it. But it's not transparent. And opaque, well, nothing's getting through. You may see a little surface light reflected, but there's nothing coming through, all right? Transmitting. Nothing's coming through that thing. It's opaque. All right. Crystal form. I may have mentioned this in lecture. Crystallinity is actually really, well, it's part of the definition of a mineral, right? And were this a mineralogy class, and or were this 1980 or so, and any time before 1980, and you were at a 4-year where we potentially had majors in geology, and every so often I do get a geology major. It's awesome. But not anywhere near even a minority of the class, let alone a majority of the class. You would spend a lot of time on crystallinity. We'd whip out our protractors, and we'd be measuring angles and all kind of wicked stuff. But at this point, when again our objective is to pass this mineral practical of recognizing the specimen and knowing what mineral group it's in, there's not a whole lot of room for crystal structure, crystal shape. But we still have to pay homage to it in some way, shape, or form. And as I said, I do that in lecture by picking the most prominent crystal form and teaching you guys about it for a little while. In here, you guys are going to use this again more as a characteristic than anything. Some of these you're going to recognize as the sort of archetypal crystal, what your brain thinks of as a crystal. Number 1 perhaps comes to mind. Okay? But in the end, as we learn, every piece of these minerals in front of you is composed of crystals. Sometimes, like in the case of number 1, it is a single crystal. Sometimes, like in number 11, the green sugary one, it's hundreds and hundreds of crystals. And even in numbers 4, 5, and 6, where there's no appearance of graininess or crystallinity at all, we still know that if you had the ability, microscope-wise to look into this, there's crystal structure there. So using this as a descriptor doesn't go a whole lot. It doesn't go very far, so to speak. But sometimes you will find it helpful. And again, what you guys tend to think of crystals, a lot of times they're cut facets we think about with jewelry, right? That's faces, crystal faces. We call them facets. They do it to diamonds. They do it to just about anything. If you've got sapphires or rubies or whatever kind of jewelry you might have. If those were original faces, it would be way, way, way more expensive. All right, so they find this rough stuff, they cut it, make it look pretty, polish it up, and mount it. And there's nothing wrong with it. Don't get me wrong. I'm not saying that. But to get a perfect crystal in nature is tough because they grow oftentimes so close together. It's going to affect the shape of the ones next to them. So that's why some jewelry is some gems are worth a whole lot more than others, even if it's still the same kind of gem. All right, finally back to cleavage. We mentioned cleavage. It was the second column in that table. And cleavage is something that we're going to have to deal with. We're going to skip 16 for the moment and go to the actual verbiage here on cleavage. Cleavage describes the way a mineral breaks naturally in nature. If you were to drop it, even whacking it with a hammer sometimes is too much unnatural force. They either cleave or they fracture. And we all know what fracture means, but a better word for your life would be shatter. All right? I just dropped one of my favorite. I like the tiki culture. You may have noticed my Hawaiian shirts here and there. So I happen to have gotten a really cool rocks or Mai Tai glass from this one place. And it fell off the shelf last week. And what does it do? It shatters, right? Every piece was a different size, a different shape. It was random. If you've ever dropped a wine glass or whatever, you know what I'm talking about, a light bulb. Well, imagine if you dropped any one of those things and it broke into perfect little cubes, or tetrahedrons or spheres or any other three-dimensional geometric shape you know the word of. And every time you dropped another one, it did the same dang thing. That's what cleavage is. It's a predictable breakage pattern. It's not random. And things in nature do that. We've introduced it into windshield glass. All right? Supposedly for the better. You still hear horror stories. God forbid somebody goes through a windshield. Sometimes the fact that it goes into those little cubes totally saves their lives. Sometimes it doesn't work out so well. But windshield glass, if you've ever seen a broken windshield, it's supposed to break into little cubes. We've introduced the property of cleavage into that glass. Anyhow, so you're thinking, all right, this should be fairly simple. What's he going on about it for? I could recognize a cube. I could recognize a tetrahedron. I get it. Well, the problem is that oftentimes you don't have that perfect little piece. You have a surface that those things broke off of. So you need to recognize on that surface or that plane how it broke. And that's where it gets tricky. And there's other reasons it gets tricky. The cube, for example, there are some, believe it or not, cubic crystals that grow that way. And they don't have cleavage. So you're looking at a perfect cube, but it's not cleavage. And then you're looking at a cube a little later, and it is cleavage. It's not a crystal. You guys get totally, and understandably so, it's difficult, but you get totally bogged down by it. What we're going to do once we get started, and please remind me if I forget, is we're going to say, okay, 1, 3, 5, 7, and 9. That's not right. I'm just making up numbers. 1, 3, 5, 7, and 9 have cleavage. We don't tell you what the cleavage is, but we allow you to get past that second column further into the table. And then once you learn that it's schmecktight or whatever, you go back and say, oh, that's 3 planes at 90. Okay, I didn't know what that looked like. Now you do. So we're going to tell you yes or no, and you're going to mark it on your things. I took cleavage, I believe, even off of these blank tables. Let me look. Yeah, because I didn't want you guys to focus on it. All right, yeah, there isn't even a column for cleavage anymore. But you're going to put a little asterisk or a little C next to it just to remind yourself that that one has cleavage. All right, so I mentioned planes a minute ago. Let's talk about how you would actually identify cleavage. And we're going to use our desks as an example. All right. You folks at home use your table wherever you're sitting at is perfectly fine. So these things have 6 sides. It's more or less a cube, right? It's a rectangle, I get that, but 2 cubes or more turns into a rectangle. But it's essentially cubic. So you've got top and a bottom, there's 2 sides. You've got a front and a back, that's 4 sides, and you've got the left and the right, we'll arguably call it. Okay, there's 2 more sides, that's 6 sides. The thing with this is you don't count parallel planes twice because it's the same plane because they're parallel. So even though your desk has 2, 4, 6 sides, it only has 3 planes. The top and the bottom, parallel, 1 plane. The left and the right, parallel. That's the second plane. The front and the back, again, parallel. That's the third plane. Counting planes is sometimes, bless you, I think, is sometimes pretty straightforward, sometimes not. You get a hunk of fluorite that has cleavage out the wazoo, and you're trying to say, okay, is this one parallel to this one? And it's like working with a dodecahedron, if you know what that is. It's just there's so many sides, and trying to figure out what's parallel to what gets a little confusing. And you see dodecahedral is on here. It's a 12-sided dice for those of you that play those games. So we got planes down. The next thing we have to worry about is their intersection, and this is why mineralogy, they love their protractors. They actually measure this stuff. Oh, it's insane. My least favorite class, actually, was 14 weeks of minerals. This one, let's go back to your desk. We already said it's cubic. I gave it away at the beginning. But what does that actually mean? Well, you know this, but you might not remember to apply it. It means that they meet at 90 degrees. All of these planes meet at right angles, right? Let's just say for a moment, though, that for some reason or another, probably artistic, one side or another was offset from the rest. So the table just had a little, the top was off just a little bit. There was a slope on one of the corners. Well, there's a word for that. It's called a rhombus. All right? It's rhombic cleavage. Yeah, most of those planes are at 90 degrees, but there's at least one set that is off. Now, if you're starting to get nervous, we're talking about planes and angles of intersection and rhombi, and don't worry, there's no math requirement for this class. Okay, so we have two really easy ways to remember this. We got cuby cube, and we got slanty cube. Okay, feel free to whip out the word rhombic if you remember it and you know it. Slanty cube works just fine in here. Somebody sat on the cube and it's all slanty now. All right. Another big one is basal. You see basal here in the middle of the screen. Basal is like, the sheets of paper in front of you right now. Okay, if you're looking at your lab book. It's like a deck of cards. It's like a stack of ream of notebook paper, printer paper, whatever. Basal is also known as one direction. All right, one plane. And what they're talking about is the top and the bottom. Now, I always overthink this as a student. Maybe you guys are one of those overthinkers as well. I'm like, okay, well, you still got the sides. No, that doesn't count. Well, why doesn't it count? Well, because it's not a plane. I'm like, but if you were small enough and right? Don't worry about that. They don't care about the fact that you could shrink yourself down to something a fraction of the size of an ant and arguably walk along that edge of the paper, and it is a plane. They don't care. They're worried about the big sheet-like structure, okay? So don't overthink that one. It's just the front and the back, playing cards, sheets of paper, whatever you want to imagine. And you might even know a couple minerals that display that property already. If not, you'll see them really soon. So that's one direction. There's more, as you see at this top sheet here, this top thing here. So truth be told, you need cleavage to get through the ID tables. But there's really only one time you're going to use it on the test, unless you're willing to lick the specimens. And some of you will end up licking the specimens. You folks at home don't get that privilege. Don't try licking your monitors. It doesn't work the same. It's for halite and calcite. Okay? And I'm going to tell you which two it is right now because you'll forget by the time we get there anyhow. For all intents and purposes, they look exactly the same to you guys. They're whitish, clearish. They're crystalline-y. They're soft. I told you about keeping your fingernails for the next month. All right. Again, you may not enter the point in your life where you're buying wedding gifts for your friends or not, but maybe you've gone to set up your apartment and you were buying glasses. And sometimes they're getting so good now, you got to tap them to see if they're like acrylic or if they're actually glass. They tap differently. All right. You're going to be able to tell with some of these specimens just kind of by poking at them a little bit if they're hard or soft, so to speak. You're not supposed to go through the properties on the test. But there are some things that you can do, as I said, to help yourselves out. Anywho, so they're both going to tap the same. They're both going to feel soft to you. And the only difference that it boils down to, unless, again, you lick one and you'll know that one is salty, halite, and the other, calcite, is not salty, is the cleavage. Halite is always cubic, and calcite is always rhombic. And it's going to be a big old hunk. It's going to be really, really obvious. It's got a lean to it. And the halite's going to look like a big old ice cube. It's perfect little right angles and everything. But you got 30 other minerals swirling around in your head, and oftentimes you get confused. Easiest way is to lick it, but not everybody's up for that. So this is the one time you actually have to use cleavage on the test. Okay, almost done, believe it or not. We got one property left. Specific gravity. Specific gravity is potentially the most identifiable property that's out there. The problem is it's so hard to measure. So hard to measure. I've seen entire rooms. This one place I taught before I got here, University of Towson in Maryland. I was there for a semester. And they had a little room off to the side, 10 foot by 10 foot, 5 foot by 5 foot, who knows, just a room. And had all this cool little stuff in there. And I said, what's this? They're like, oh, that's to measure specific gravity. I'm like, no way, I've heard that doesn't work. And they're like, yeah, it never works. They had a special room for it, and it still didn't work. It's really simple, too. It's kind of related to the density of the material, all right? And kind of like when you sit in a bathtub and the water level goes up, or a barge. You guys live by the canal here, all right? A barge comes up or down the canal. Sometimes it sits lower, sometimes it sits higher. Really simple idea. You weigh a piece of specimen. You put it in water. You measure how much the water goes up. And it's going to vary on whether or not it's density, but you have to have the weight anyhow, as to how much that water goes up or down, or doesn't go up, I should say. It never goes down, but how much it doesn't go up. And it's even a simple equation. It's not like it's not horrible. But you will not get the same answer 3 times in a row. If the classes change, if the humidity is different or the temperature is significantly different than it was the week before, it is that tiny of changes that matter. And that's why it's so hard to measure. But it's just miserable. What you guys will acknowledge, though, these are all arguably about the same size pieces. Okay? You're going to come through and all of a sudden you're going to pick up something and be like, wow, that's a lot heavier than all the others. Well, it's more dense, but we won't argue with you. It's going to feel heftier. Think about if you ever helped anybody move, or maybe garbage bags. And, everyone moves in like with liquor boxes or whatever. They're all roughly the same size, but you get to one, you're like, oh my God, what do you got in here? Rocks? And, oh yeah, sorry. It's totally different than the underwear box you just carried out. Same thing with trash. Okay? So you're going to get to one of these minerals and you're going to recognize it's super dense. Make a note of that, because that might help you on the test. Or one of them that feels particularly light. That could help you on the test. It's a big tip, actually, when we get to rocks. We don't talk about specific density with rocks. But coal, you're going to have 17 black rocks, and you guys are really going to be struggling to keep them all separate. But coal feels like you're lifting air, practically, compared to the other rocks. It's so low density. It's the same idea. So again, we don't have a column for... So just make a note of it. You never know when specific gravity will help you. There isn't a column for it, but put it in your personal notes. So what do? Well, basically what we did already. I'm going to skip to... actually, let's go back to 2B for a minute. So I told you that you would know going into the exercise which ones had cleavage or not. So you would know right now that number, what are we doing, 2? Number 2 does not have cleavage. Now again, that's not the biggest help right now, but it does get rid of one option. It gets rid of that second one there where it says white, and then under cleavage it says 2 at 90. Well, we now know that that's not an option anymore. Clear to white is still an option. White is still an option. And white to gray is still an option. Now let's go back to our luster. Before we just said it was non-metallic. What do you guys think? Are we looking at something that's pearly or earthy, or something that's vitreous? Pearly. All right. Anybody else? Let's keep the specimens in the center of the table if we can, please. That way everyone gets an opportunity to look at it. Ladies group 4, what do you think? Is it glassy or is it sort of just satiny? You're not penalized for mistakes at this point. You just, you're doing a scientific method. You're guessing, right? Educated guesses? Give me a word. Glassy or satiny? I didn't hear you. Glassy, all right. And group 3. Remember, satiny is kind of pearly. Glassy is the vitreous one. Glassy, yeah. I agree. And again, this is personal thing. You could certainly go with pearly, all right? And then you might find out you're right, you might find out you're wrong, and then you'll see something that is pearly a little bit, and you're like, oh, that's what pearly is. I get it. But yeah, I agree with a lot of you guys. This is probably vitreous. All right, now again, that still doesn't take it too far. That narrows it down to two of them. Clear white or white. No cleavage, vitreous. They have the same hardness, 7. So, translucent hexagonal crystal or opaque and amorphous? What does amorphous mean? Not quite. Not quite. It could be interpreted that way. But we're looking for something a little more. I know where you're going with the solid, but that's not that doesn't help right now, probably. All right, what does the prefix A mean? Not. All right. And morph. Now, morph people tend to think of changing, right? But what are you changing when you're morphing? You're changing your shape, right? So morph is shapes. So amorphous means not shaped, unshapen. It's a fancy word for a blob. So is this an opaque blob or is this a see-through hexagonal crystal? See, it's a not see-through blob. Yeah, it's a glassy, opaque blob. So more than likely this is what mineral? Milky quartz. Yeah, and now some of you knew that 48 minutes ago. So be it. And that leads to something else we'll talk about in a minute here. But yeah, more than likely milky quartz. This is why we do this in pencil, okay? Because it might not be milky quartz when all is said and done. Now, what do you do with that knowledge? Why don't you go to page 25, and I'll get out some pencils here again for those of you that might need them. We do skip around some numbers. Well, we don't skip around. We do skip some numbers. But 1 through 15, which I believe is what fits on this page, does not have any skips. So you could number down that first column without any concern. I wouldn't go past that till I post the numbers on the board next week. And for those you folks at home, you'll see the numbers as well. This one is broken, but so there's a couple pencils. So 1 through 15, color. All right, so we're going to jump to number 2 because we want to do these in order. You'll go back to 1 in a moment when I set you loose. You don't want to write light or dark. You want to write the actual color. So what are you going to write? Yeah, most of you will write white to clear. But again, if you've got a better word in your head, write what you want. I'm not grading your descriptions. And again, don't necessarily write down what your neighbor's writing if it doesn't make any sense to you. Somebody might say, cloudy or something, and that's fine. It's not really a color, but I get it. I get it. All right, luster. We're not going to write non-metallic or metallic. We're going to write the actual word, which was vitreous. Yes, vitreous. Hardness. Looking at the sheet, we now know that it has a hardness, if we're correct, and you are on this one, I'll tell you that. You know it has a hardness of 7. Excellent. Description. I do not recommend just writing down opaque and amorphous. Write down something that actually means something to you. I've kind of been preaching that all along. All right, there's little sense in just parroting back what's on the previous page. So if you want to write cloudy, glassy blob or something like that, please, feel free. Description is totally you. Mineral name, milky quartz. Mineral formula was SiO2, if I'm not mistaken. And we're going to leave the last column, mineral group, blank for a while, at least till the end of next week. Next week, you guys come back, and I don't want to talk like this the whole dang time. But at the very end, we will need to take 5 minutes or so and talk about mineral groups And for you folks at home, that is a separate lecture cast. All right, you listen to it when you want to. But these guys, I'm going to do it at the end of the second week. Now, I want you guys to go in order. So when you're done here in a couple minutes, you're going to go back. You're going to do number 1. You skip over 2, do 3, 4, 5, 6. Today, I want to just get as far as 7 or 8. You guys have been listening to me for a long time. We have plenty of lab time left, arguably, but we're just going to get a little more than half a dozen done. I want everyone to work together. None of this left side of the table does evens, right side does odds, divide and conquer kind of thing. Because guess what? You're only going to learn half of them then. All right? You learn these by doing them. Also, again, try to stick together. There's, especially in the groups with 4, okay? Somebody might want to spend a whole lot more time on a specimen than the majority of the group does. Or they just, won't engage. I will try to keep tabs on that and try to give gentle pokes to the group, okay? But sometimes there's just nothing to be done about it. If you want to spend more time than your group does, these are in the library. All right, that goes for you folks at home too. If you want to see these in person, they're on Rome campus, they're on Utica campus in the library. Go to the place where you check out books at and ask them to see the rock and mineral kit. Okay, they're there. I definitely recommend that before the practical. Anywho, so stick together, work together, and this is one of these things where you hardly ever hear a teacher say this, but I'm going to yell at you if I can't hear you talking. All right? We want you to work together. We want you to interact. And again, you folks at home, if you know someone else that's taken the class, maybe try to get together and work on these. All right, you guys, I'm going to let you go.